So we're moving on to Unit 7. I know we did Unit 8 before, now we're going backwards to Unit 7, it's going over polygons and quadrilaterals. So we're going to be looking at shapes and sides of shapes and angles of shapes and trying to put that all together and so that we know different properties about different polygons and quadrilaterals and etc. So we're starting off Unit 7, Section 1. I put them, since I gave you the packets, the packet all together this time, I put each section name at the top so that you would be able to know where we're at as we go. The first section is interior and exterior angles of polygons. So we're going to look at different shapes. We're going to look at different polygons. Polygons are means shapes. Well, and then they're named based on the number of sides they have. So the first polygon, since there is a one-sided shape, it's a circle, but that's a little bit different. We get into that in a different chapter. But there is no two-sided shape. We start with a three-sided shape. So the first three-sided shape, or the only three-sided shape, we call a triangle, right? So the number of sides on a triangle is 3. We call a four-sided shape a quadrilateral. Now, I know we think rectangles and squares, but there are more four-sided shapes than just quadrilaterals. This, I can draw a quadrilateral here. That was terrible. That's terrible too. Let me see if I can draw one. Well, here. That's a four-sided shape, but it's not a rectangle, it's not a square. So there's different kinds of four-sided shapes, so we call those quadrilaterals when we're talking about just in general. Then we have five-sided shapes, which are called pentagons, and six-sided shapes, which are called hexagons. These first four we've dealt with in the past, so we should know these pretty well. And then I didn't give images of these just because we don't really look at the images so much. We're more going to look at patterns once we get to these. But a heptagon is a 7-sided shape. An octagon is an 8-sided shape. A nonagon is a 9-sided shape. And a decagon is a 10-sided shape. After 10-sided shapes, they don't have special names. We just call them gons based on their side. So what that means is, let me find a little spot to write. If I have a shape that has 16 sides, I'd call that a 16-gon. They don't have special names after that. It's just the number of sides they have and then gon afterwards. So now I want to look at what we call this interior angle sum. So the sum of the degrees of any polygon can be determined by the number of triangles that can be drawn within the polygon. So we want to look at this table here, and we want to look for a pattern to find the sum of the degrees in any polygon. So let's go through and let's just identify the number of triangles in each polygon. Okay. The number of triangles that can be made up from a triangle are...
With the following students, please report to the office. Cody Bourbon, Chase Bourbon,
are just
John Kyler,
one.
and Haley O'Brien.
Why do they have to do announcements when I'm trying to record? So you can only make up one triangle in a triangle. You can't split the shape anymore to make any more triangles. You can't separate it, at least not with connecting angles. Yeah, I can do one like this, but that's not connecting the angles together. So in a quadrilateral, I can cut this one by the diagonals, either one, and I can make two triangles. Then I can cut a pentagon. I can start at one angle, and I can cut into two different places and make 3 triangles. I can cut a hexagon into 6 triangles. not 6 triangles, 4 triangles, because I can cut from one angle, I can cut into, I have 3 other angles that I can connect to, and that forms 4 triangles. So if you notice a pattern here, as the number of sides goes up, the number of triangles that can be created goes up. So go ahead and fill in heptagon, octagon, nonagon, and decagon, what you think the number of triangles could be when formed from these shapes. Then I want to look at the sum of the interior angles. So we know the sum of angles inside of a triangle. This is an angle, this is an angle, and this is an angle. That's 180 degrees. We've known that for a while now. The sum of the interior angles of a triangle is 180 degrees. So think about when we look at a quadrilateral. We formed this shape, or we split this shape into 2 triangles. 2 triangles. So the sum of the interior angles of this quadrilateral, we can split into the angles of those triangles. Okay? So in this triangle, I know the sum of my angles is 180 degrees. In this triangle, I know my sum of my angles is 180 degrees. So that means the total sum of interior angles in a quadrilateral is 360 degrees. It's 180 plus 180. Because I formed 2 triangles. So then when I look at a pentagon, since I formed 3 triangles, I know that this triangle has an interior angle sum of 180, this one has an interior angle sum of 180, and this one also is 180. So to find the total interior angle sum of this pentagon, I add all 3 of those together. Or I can take, it's the same as taking 180 times 3. Okay. Which gives me 540 degrees. So the sum of the interior angles, all of these angles inside of here, all 5 angles inside of my pentagon, the sum, if I knew all of those and I added them all together, it would be 540 degrees. Then I look at a hexagon. You could probably maybe start to see a pattern here. Again, I have 4 triangles that I can split this into, each with an angle sum of 180. So to find the interior angle sum of a hexagon, I do 180 times 4, which gives me 720 degrees. So look at how the number of triangles created in each shape relates to the sum of the interior angles. Use that to fill in the rest of this table. This needs to be done as part of your grade on your notes grade. Okay, so take a second and do that. So we have this formula, which we call the sum of the interior angles formula. So if we have some letter N that represents the number of sides of a polygon, then the sum of the interior angles, we'll call that S, can be found using the formula S equals N, the number of sides, minus 2 times 180. And notice that's what you did up here. We took the number of sides, minus 2 to get the number of triangles, and then we took that times 180 to get the sum of the interior angles. So we also have these things called regular polygons. So a regular polygon is one in which all sides are equal. And remember, when I have a shape where all sides are equal, all angles are also equal. So to find the measure of an interior angle in a regular polygon, we use what we call S over N, where S is the sum of interior angles, and then divided by N, which is the number of sides. So if we wanted to find, since a regular polygon has all angles equal to each other, if I wanted to find the angle, or what that angle is, I can take this number here that I find here divided by the number of sides. So let's flip this over and let's try and do some practice. So I want to find the sum of the interior angle of a 15-gon. So this is one of those gons I was telling you. That means this polygon has 15 sides. So if I want to find the sum of the interior angles of a 15-gon, I'm going to put my formula up here so that I have it with me. So I want to find the sum of the interior angles of a 15-gon. That means I take S equal to, that's what I'm trying to find, N, which in this case, N is the number of sides, so this shape has 15 sides, minus 2 times 180. So when I do that in my calculator, S equals 13 times 180, which then gives me 2,340. So the sum of the interior angles of a 15-gon is going to equal 2,340 degrees. Since this has 15 sides, that means N equals 15. I was going to put that up there. So you're taking the number of sides, subtracting 2, and multiplying it by 180. That's going to give you the sum of the interior angles of a shape based on the number of sides. Okay. So now I want to look at number 3. What is the measure of each interior angle of a regular pentagon? So regular pentagon, that means that means my number of sides is 5. And that also means that all of those angles are equal. So that means I just need to find, well, first I need to find the sum of the interior angles of a pentagon, which from the front I know is 540. I could also find that by doing S equals 5 minus 3 times 180, which would give me 540. So then, to find what each interior angle is of a regular pentagon, I take 540 divided by 5, which gives me 108 degrees. So that means if I have a pentagon, it's going to be a really bad pentagon. Let's try that again. If I have a pentagon here, this is a regular pentagon, that means all of these angles are equal. Each one is going to be 108 degrees. Now this is only because it's a regular pentagon. So go ahead and try 2 and 4. Then we'll move on to what we call the exterior angle sum. So exterior angles are always supplementary to their adjacent interior angle. So on the polygons below, we want to find the measure of each exterior angle along with the sum of all exterior angles. So that means I want to go through and I want to find, see, this is an exterior angle. If I continue to draw this side of my triangle out this way, the exterior angle is what would be formed adjacent to this interior angle that's next to. This is an exterior angle also. This is an exterior angle. So I need to find the measure of each of those angles. Now remember, supplementary angles add up to 180 degrees. So this angle is going to be 180 minus 79, which gives me 101 degrees. And then this angle is 180 minus 40, which gives me 140 degrees. Then this angle is 180 minus 61, which gives me 119. It's terrible. 119. So then, to find the sum of all of those exterior angles, I add them all together. So 119 plus 101 plus 140 is going to add together to give me 360 degrees. So I find the exterior angles of, or all the exterior angles of this triangle, add them all together, it's going to equal 360 degrees. So if I want to look at a quadrilateral, I do the exact same thing. This one's going to be 56, 104, 91, 109. Okay? When I add all of those together, I also get 360 degrees. So when I'm finding these exterior angles, I'm taking 180 minus its adjacent supplementary angle, or its adjacent angle. So then I want to look at a pentagon. So this angle is 180 minus 98, which gives me 82. This one's 59. This one's 93. This one's 50. And this one's 76. Once again, I add all of those together. I end up with a sum of 360 degrees. So and then if I look at the hexagon here, there's all of my exterior angles. So this one should be 65, 51, 56. That's not an 86, that's 56. 68, 57, and 63. So again, when I add all of those together, I end up with a sum of 360 degrees. So you should see a pattern here. So we can come to the conclusion that the sum of the exterior angles of any polygon, I can't spell, of any polygon is 360 degrees. So it doesn't matter how many sides you have, doesn't matter what those angles are, the sum of the exterior angles of any polygon is going to be 360 degrees. So let's look at number 5. So now I want to find the measure of each exterior angle of a regular hexagon. Remember, regular hexagon, or regular shapes, regular polygons, have all angles the same. So if I have a hexagon down here, again, I'm going to try my terrible drawing. If I have a hexagon here, and this is a regular hexagon, that means all of these angles are the same. So that means all of their exterior angles are going to be the same as well. That's what I'm missing there. That's what I'm missing. So all of those are going to be the same as well. So to find the measure of each exterior angle of a regular hexagon, I know what the sum is. And just like my formula on the front page of the interior angle of a regular polygon, same works for the exterior angle of a polygon. I know that the exterior angles are all going to add up to 360 degrees here. So that's my S, my sum. So to find the measure of each exterior angle, I take that sum divided by the number of sides in, which in this case it's a hexagon, so it has 6 sides. So 360 divided by 6, which gives me 60 degrees. So that means each of, zoom in on my shape, each of these angles, exterior angles, is going to be equal to 60 degrees. So remember, when it says regular hexagon, that means all of the angles are the same. Okay, let's look at number 7. If the exterior angle of a regular polygon, again, I'm in a regular polygon, measures 12 degrees, how many sides does the polygon have? So, if each of those exterior angles equals 12 degrees, I need to find out how many sides the polygon has. So notice how when I was up here, I was adding all of the exterior angles together to get the exterior sum. Since they are all the same, I can multiply the number of degrees of each angle times however many sides the polygon has, and it's going to equal 360 degrees. So since we're trying to find the number of sides, we're going to let that be x. That's something we don't know. So I can take 12 degrees times x, however many sides that is, and that's going to equal 360 degrees. Then I solve for x, so I divide both sides by 12. X equals 30. So that means this polygon has 30 sides. So it'd be a 30gon. So if I were to draw out a regular 30gon, a 30-sided shape where all the angles and sides were equal, every exterior angle would equal 12 degrees. So use the exterior angle sum, the interior angle sum, and then pay attention for those interior angles of and exterior angles of regular polygons. You need to have this table filled out before I check these, and then you also need to have all of this filled out, and then you should be able to do 2, 4, 6, and 8 with no problem. Okay.